Hi, this is Dan Bullard, retired electronics engineer, sitting on the front deck of my houseboat. I want to tell you about the ITS 9000 EXA. When I was at Credence, I was traveling way too much, and I finally got a job from these guys at Schlumberger in Intel, because there's an Intel plant. It's not too far from my house in Lowell, which was great. And so I gave my notice, and they tried to offer me a this and that and the other, and said, "Oh, you'll never travel again." I'm like, "No thanks." I mean, I love my boss. He was a great guy, but I just didn't believe him. You know, there's no way I could be an apps engineer and not travel when you work for the International Apps Division. You just can't do that. So I took the job with Schlumberger, and I had to go to train right away. And so all my friends were like, "Oh, Dan, that's funny. You quit so you could stop traveling, but you had to travel. Had to go to San Jose for training." So I went to San Jose for 5 weeks on training. And so I went to school on the ITS 9000 GX, which was their 100 megahertz tester. And the GX was a pretty interesting tester, all liquid cooled. And so the whole tester was plumbed with Freon. They used Freon to run through the pipes and cool all the components throughout the tester. And so when you went to pop out a board on the GX, they were big boards, you know, big boards. They had pipes running in there. And so you had to disconnect the pipes after turning off the power, disconnect the pipes, and then pull out the boards, and it's full of liquid. And so you had to drain the liquid before you shipped it back for repair and put the new board in, and of course they would run new fluid in there. But it was all liquid cooled, and it was Freon. Unlike the HP, the Agilent 83,000, they used water for liquid cooling. The GX used Freon, but they did have a heat exchanger using water, and that was fine. It was, you know, your plant had to have a heat exchanger to get rid of the heat, and had to have water, so the water would cool down the Freon. It was pretty clever. But if it weren't for the water and the Freon, the thing would be enormous. But it was relatively small, and this is a good look at it. It was this is a used one that they have for sale. It's a big machine, big machine. Here's a test head, and those are coaxial pogo pins. I thought the Credence had patented the coaxial pogo pin, but no, they had patented their version of the coaxial pogo pin. And a pogo pin is basically just like a pogo stick. You put the load board on top of the test head, and you lock it down, and that squishes the pogo pins, and so the pogo pin it's a spring-loaded pin, so it makes contact with the load board and sends the signal up to the device or down to the tester from the device. So it's a spring-loaded pin, and the coaxial pogo pins had an inner pin and then a circular pin around that, and they were all on a spring-loaded assembly. And so those carried the signals up there. 640 pins. Now that doesn't include the ground or the 6 utility pins per 8 pins. So there's like pogo pins all over the place. It's like 1,200. Then you throw the utility pins in there. Utilities, they're relay drives. So they're for relays on your load board. So it's like 2,000 pins pushing up against this load board. So when they lock those boards down, those load boards are under an immense amount of pressure, because the pogo pins have a lot of pressure coming up. One at a time, you know, individually they're pretty small, but when you have 2,000 of them pushing up, there's a lot of pressure on it. So it was an amazing machine. And here you can see on the test head, some of the pin cards are removed, and they had airflow cards in there to keep the air from moving around, getting around the Freon-cooled components and stuff. But those are just blank pins for that particular customer. That customer didn't need all 640 pins, so it worked out fine. They just had blank boards in there for those. But they kept the airflow from infiltrating the rest of the test head. So the GX was an amazing machine, and the EXA was based on the GX. And so GX with EXA meant it had mixed signal. So it had an AWG and an analog capture instrument, and they were fantastic, fantastic. The digital was sequencer per pin, which they designed the whole ITS 9000 line around sequencer per pin. And so what you could do is you could take high-low or whatever logic simulator you were using and take the vectors directly from that right into the tester and use that for stimulating the device. And what it does is the actual simulators have, for each pin, you have a time up and a time down. And so you basically don't describe your waveforms as a 1 and a 0, 1 and a 0, 1 and a 0. You describe it as an edge up at this time and an edge down at that time. And that's how the tester was built. It didn't have a T0. Most testers have a T0 where there's like, you know, some fixed time between T0s, and then you could set the edges relative to the T0, and you just repeated that again and again and again. That's not how the ITS 9000 worked at all. It had something called sequencer per pin. And so you could put an edge pretty much anywhere on the pin, anytime, and it got to be a real pain in the butt. Well, Intel and everybody else hated this system, but they bought it anyway because it had such impressive performance. And so Intel forced Schlumberger to build it as a T0 system. And so they would take the vectors, the T0 based vectors, and turn it into sequencer per pin vectors. And the software for that was incredible. So they had this big, you had to take your vectors and run it through this big thing that would, software tool that would convert it into the sequencer per pin vectors. And of course then if something went wrong, ooh, boy, you're really struggling to make it work. But anyway, it wasn't a very popular system, but Intel loved it. And so they used it because it was 100 megahertz for the GX, and then 200 megahertz for the IX. I don't know what happened to the HX, they must have skipped it. But the IX was 200 megahertz, and then the KX, and I got to experiment with the KX. KX was 400 megahertz. Now there's a thing called MUX mode. So the 100 megahertz system can operate in MUX mode, which basically takes two pins and uses them together so that the two pins can double the frequency. And so two pins go into one pin, and that doubles the frequency. So the GX could go up to 200 megahertz, and the IX could go up to 400 megahertz, and then the KX could go up to 800 megahertz. That was incredible back then. This is back in the 1990s, okay? So it was incredible. But the tester was very, very cool. It was very fast and very, very accurate. I mean, I got time on the KX. They installed the KX at Ronler Acres in Intel up here in Oregon, and I got to play with it. They told me they wanted me to look at it because I was the expert at testers, and I was. And so they gave me this KX to experiment with, and I went and schmooed 8 pins together, and I found that the biggest inaccuracy was something like maybe 10 picoseconds. 10 picoseconds between 2 pins for drive and compare. So the spec was something like 100 picoseconds, but it was way better than that. It was like 10 picoseconds. So incredible. So I was in Schlumberger in digital, working mostly on the Pentium 2 and Pentium 3. I was there for first silicon for the Pentium 3, and my boss knew I loved mixed signals, so he decided to put me into an EXA class down in San Jose. So it's a 1-week class. So they told me I go down there, And I decided, okay, let me, it's summertime, kids are out of school, grabbed the wife and the kids, took them all down to California. I took my kids up to their grandparents' house, my parents, up in the mountains in West Point. And then me and the wife went down to San Jose to go to training. And we got our hotel room and, I went to training. And so I was there I wasn't quite there for a week. I went down there and I got in the class, and the instructor was a nice enough guy, but he was kind of new to mixed signal, which was a problem for me because I was an expert at mixed signal by then. And one of the guys in the class was named Leroy, and I had an incident with Leroy years ago. I was teaching an STS 6000 class, and here's an STS 6000. And in the STS 6000 class, Leroy was an expert. And so he was like grilling me on this and that and the other and constantly pounding me. Oh, you're wrong about that, you're wrong about this, you're wrong about that. Well, I didn't know much about the STS 6000. I was kind of filling in for another guy. So I took it. But in this case, the tables were turned because Leroy didn't know anything about mixed signals, so the tables were turned, and so he was sitting there, and I couldn't believe how much he was sucking up to me. He was sucking up to me like, oh, you're an expert at this stuff. And so the problem was, like I said, the instructor didn't know very much about mixed signal, and so I was trying to help him out. I'm not, I'm a viciously mean guy or nothing. I was trying to help him out. I would say, but well, you could do this, and he didn't know all these points, and so I was kind of trying to help him out. But I knew that I was annoying him, so I was doing really good. And so I started working on, because I loved ASAP, I started working on something on this PSR test that I just did for chromatic. And so I wanted to do it with them too, show the students how to do FFTs and take the results and all that stuff, because I developed it all and I did this in just 3 days, I picked up the tester super fast because it was like so easy for me. The nice thing was the DSP stuff was all, grab a box, move it over here, connect it to this box. It was really easy to do. So it was great. And so he agreed, and I says, so if I teach this class, you'll give me my diploma on Thursday, and then I'll get out of your hair so you can finish up the class on Friday without me like bugging you all the time. So he agreed. I was trying not to bug him, but it was obvious I was annoying him. So what I did was I gave the class. It actually took like 3 hours. I gave the class. He gave me my diploma on Thursday, and I got the hell out of there, and I drove up to the mountains and got to hang out with my kids and their grandparents, my parents, and had a good time in the mountains up there with them. They got a whole week with my parents, and it was great. And it was all paid for by Schlumberger, so it was great. So I got the family a trip down to California to visit. The kids got to visit their grandparents, and the company paid for it. It was great. But I never got to use it because I was doing the IX, ITS 9000 IX and KX up at Intel Ronler Acres, where, like I said, I helped introduce the Pentium 3. And the Pentium 3, I was there for First Silicon, and a funny story, my wife, they had kids coming from school to play with my kids, and one of the dads showed up to pick up one of his kids, right? And my wife says, oh, you're wearing a pager. Are you at Intel? Are you waiting for First Silicon? He's like, how did you know? That's supposed to be a secret. She says, my husband works at Intel too, and so he's waiting for First Silicon on the Pentium 3. So we were waiting for First Silicon. So when it came out on a Sunday. And so I had to go to work on Sunday at 4 p.m. and I had to do an 8-hour shift working on the Pentium 3 First Silicon. And it was getting past midnight, and I was supposed to go home at midnight because that's all Intel paid for, right? And the guy I was working with, we're sitting on the test floor, the guy I was working with was saying, "Oh, you can't go home yet." I said, "Well, look, you know, the contract says I have to go home at midnight." He says, "No, I need you here because I'm working on this thing and I might need your help." Dude, I got to go to work at 8 o'clock in the morning, you know? I'm not going to stay up all night and then go to work at 8 o'clock in the morning. That just doesn't happen. So finally, like 12:30, he let me go home. So I went home, got some sleep, went back to work at 8 o'clock in the morning at Intel. But I enjoyed my time in Intel. It was really kind of fun. I got a different perspective. And in the end, I don't know if I had anything to do with it, but in the end, Credence bought Schlumberger, bought the test division from the company Schlumberger. And so they ended up getting involved in that tester. And I don't know, I mean, I did give them, the Credence people, a briefing on sequencer per pin and how the ITS 9000 worked, and maybe that was enough to entice them to buy them up, I don't know. But I did enjoy my time at Intel. And my time at the class on the EXA was great because I was so up to speed on mixed signal. The poor instructor wasn't. I felt really bad for him, and I tried to help him get through it, but you do what you do, and then, you know, try not to be an asshole. So anyway, so once again, from the river to the temple, see ya.